Okay, this is video 2 for forced air system, and this video we're talking about the different kind of duct system available for us. Of course, it's a very vast subject with a lot of topics and a lot of types of registers, air distribution and prices. We'll try to touch base on the main ones and how do they differ. So the first system we have is the plenum system, and let me change this. We also have the extended plenum system and reducing plenum system. By plenum we mean a big trunk and branches, and we also have the perimeter loop, and we'll talk about what are the differences. So the first one is the plenum system. It's very suited for the outlet of the main trunk is very close to all the units. It has supply diffusers located inside the walls, and it works better with fossil fuel system. Why? Because they have higher temperature, more delta T, because if you guess it now, you'll be losing a lot of heat. So fossil fuel can go up to 130, and that's why when we saw that temperature difference, we said there is 130 minus the room temperature was I think 70, and that will give us 50 degrees, and we had even 60, so it was kept at 60. So it can reach at 130, and that's shooting for the best case scenario. So let's see what it looks like. This is what it looked like. This is the plenum system. We have one big unit, and in this case it is placed in the attic, and this is the supply plenum. It's very small, and it's one piece that supply through flexible duct to all the units system. Then we have the extended plenum, where we don't branch directly from the stem. We go all the way a little bit further for longer structures. And if you remember the class, the air conditioning we have in the class, we have a simple plenum system with flexible duct. That's what it looks like. The extended plenum is kind of longer, and so we can have a big trunk that goes all the way to the last point to have the branches have less pressure in them. And this is what it looks like. So you have the plenum, this is the supply unit, and the plenum going all the way along the house, and we have branches coming from that trunk with the register for each one of those rooms. So this is better distribution. It's even quieter because the velocity here is going to be a little bit slower, and each room will get a fair share of the cold air, hopefully at the same temperature. Then we have the reduced plenum system. What the main purpose of the reduced plenum system is to maintain the pressure. If we look back at that slide, probably you've seen the plenum is in one size. So this, if we have a very long system, and if we notice here, this is my supply duct, and this is the regular plenum. So we kind of have like not that far of distribution. If you were to put the supply unit here and you'll go all the way here, probably you have noticed that the pressure here is more than the pressure here. So if here you start at, like, let's say just 2 psi, probably it's 1 psi in here. Okay, this is what it looks like. You'll have the supply unit at one point here, then we keep reducing the pressure as we go along, and we said the flow rate equal velocity times area. So as we reduce the area, we'll increase the pressure at the velocity, and the pressure will equal velocity square times density. So the pressure is related to the velocity. So by reducing the area, we will reduce the pressure as we go along. Again, we have branches coming out of the main trunk, the reducing plenum. The last system is the perimeter loop system, which we will go around the house, and it's very ideal for concrete floors and in colder climate because we do not require a lot of heat and we do not require a lot of cooling system. So it's very slow acting. It is also very kind of does not give you a lot of pressure because we have to go all around the house, and keeps the slab at more even temperature, and it comes from the bottom, not the top, and provide the same pressure outlet. It looks like. So this here is our perimeter loop where we supply pressure at different points in those registers, and the air will go around in a big loop and comes back to one register. And another point that we have to always think about is where do we keep the return line? So sometimes the return line comes from one central unit in the house and goes in, and we anticipate those doors to be slightly open and there's some kind of breathing to it. But again, that will, having only one register to go back will kind of put a lot of work on the inducer fan to pull in air through that register. Especially, again, there's always a filter in those registers. If the filter is clogged, probably the work done by the inducer fan motor is going to be a little bit large. Okay, now I would like to talk about duct material. Again, there's a lot of work including the duct. Sheet metal work is very desirable license to have if you have that. And for years, we always use sheet metal and galvanized steel because it has very good mechanical structure, and also it has better ways for insulation. You can put some more types of insulation on it, and it can withstand a lot of impact, and it does last longer, and it does not deteriorate with heat. There are other duct material. We have aluminum duct sheet. We also have foam that's galvanized with aluminum. We have fiberglass duct boards. Those are very fragile, and also you have to check for the temperature ratings, whether they're okay for heating or cooling. We have the spiral duct material, which comes in a big piece of tape that is put together in a spiral to make a pipe. So probably you've seen those, and there's a machine that seams them together, and you can change the size as you go along in terms of diameter. That's a spiral duct. And we also have the flexible duct. That's basically looks like a hose, and it has some spring inside to keep that duct open. Galvanized steel, they are measured by gauges and thickness, and again there's a lot of art and metal work involved with doing the sheet metal and how do you do the connections for those. And again, that's just the definition of what is the gauge for that sheet metal. If you have a sheet metal license, probably you have been through the gauges and how much pressure can go on that sheet metal. It can be round, square, or rectangular. Those are the shapes that we have. I haven't seen anything more than that. There is no oval, there is no triangle, either round, square, or rectangular. And again, this is going to be 1:1 ratio, and it's going to be 3:1 ratio. Fiberglass, they can be flat sheet that you can fabricate, cut, and use duct tape. That's where the whole duct tape idea started, because it was used to put duct together. Duct is usually 1 inch thick, and it's already insulated. It has aluminum foil from the outside to eliminate the heat loss. Not eliminate, maybe reduce the heat loss. It's going to be still a little bit warm. There are special knives to cut those duct work and seam them together, so they all get stable together. And sometimes we put some support in them to keep them together. But again, it's not as how can I say, leak proof as regular GI galvanized steel duct. Spiral metal, they are used more on large systems. Comes in rolls of flat iron metals. Again, it's big and flat, and there's a groove in one side here that they can hook them together, so it can be hooked while you spiral it around. And if you think about it, like duct metal is what makes duct work very expensive is it has sometimes to be prefabricated in a shop and delivered with a truck to be put in spot. So this was a good idea where you can manufacture that on the spot, again along with the fiberglass. Flexible duct, they come in different diameters. Again, it's a thin sheet with a spiral inside that keeps it open, and reinforced with aluminum foil backing. What else? Have some insulation. Sometimes you can put insulation around it, and we want to be as short as possible. Why is that? If you look at that material, it looks like that, and this is where we have our metal support. So if we look at the velocity of the air here, it's going through a lot, and that will have really high pressure loss, high pressure drop. So you want to keep it as short as possible. High pressure drop. More friction losses than duct metal, again, because it's not smooth. The air goes up and down. There's a lot of spirals, and air is very air can generate a lot of turbulence because we are pumping it very fast. And it should be as stretched as tight as possible because, again, you want to eliminate those wrinkles and you don't want to collapse on you. This is flexible duct, and again, we can have fasteners that goes inside from the main trunk into the register, and this one is a floor register here. So you can see how convenient that is. You just connect them and maybe fasten them to the ceiling, but again, it's not the best solution, but it is one solution depending on how much CFM you require. Duct air movement. So again, branches ducts are fastened to the main trunk. Takeoff is where we actually install or connect the branch to the main trunk. Air moving has inertia. What does that mean? It means that it won't move in a straight line. So once we turn the air, so air as air moves, it wants to go in a straight line. If we turn it, it will have to hit the wall here and spiral again. So the more turns we have, the more vortices we will have, and the less the air will have smooth flow. It's kind of like water, but again, because we have high velocity in the air, we have more possibility of producing vortices and choke points for airflow. Main supply duct. These are the takeoff fittings. This just to smooth out the flow, especially if we are reducing and eliminate the back pressure. We don't want the air to hit here and come back again. And these are the connections. Dampers. So remember when we did zoning with water and we used zone valves to isolate? The same thing we can do with dampers, and those dampers now comes in really convenient forms, and they can be controlled remotely, and we can be half open or half closed, half open or partially closed, and also we can isolate. Some of them are manual and some of them are also motorized. So let me, so yeah, these are the dampers. So basically it's a door. Some of them, again, these are one are manual. For new duct systems, probably you'll see those dampers along with a control system here that will turn this lever on and off automatically without the need to do that by hand. And they basically reduce or increase the pressure. And again, if you notice that if you close the damper here, the air is still going all the way here and it's spiraling. So you'll see some noise when you close the damper. Blending air with the air-conditioned air with the current air. So blending is another branch or another science or aspect that we have to think about when we want to mix the air inside. When possible, we want to blend the inside air with the incoming air. So what does that mean? Let's look at this room here. We have, this is my duct and this is my register. Where do you want to shoot up the air? So whenever possible, you're blending the inside air with incoming air. So mixing the air, again, as we said from the first class, we want to have uniform temperature. So they say it's good to direct the air to the incoming air to the wall. So when it hits the wall, so this is gonna go evenly to the bottom. But if we direct this to the wall, it will hit the wall and spiral back. It doesn't have to be directly towards the air, but you can have some veins hitting towards the wall to spray more and spread the air more inside the room. So it makes sense that cool air will distribute better from the ceiling because it's going to drop down and diffuse. If we have hot air, we want it to be from the bottom because hot air will rise, so it will diffuse better. Place diffuser next to the outside wall. Makes sense. Kind of like outside wall is here is when you this is where you actually lose more heat. And again, for register, they are rated based on this is my register here. They are rated on two things: is the velocity that comes out of it and the throw and angle. The throw is how far does it go, and the angle is what is the deviation from the straight line that goes from the register. Okay, I'll pause for this video and start the next video.